All right, let's take a look at Chapter 8, Consumer Mathematics. Section 8.4, Annuities. We'll want to calculate the future value of an ordinary annuity and perform calculations regarding sinking funds. Annuities. An annuity is an interest-bearing account into which we make a series of payments of the same size. If one payment is made at the end of every compounding period, the annuity is called an ordinary annuity. The future value of an annuity is the amount in the account, including interest, after making all payments. Suppose that in January you begin making payments of $100 at the end of each month into an account paying 12% yearly interest compounded monthly. If we compute how much each deposit contributes to the account and sum these amounts, we will have the value of the annuity on July 1st. If we compute how much each deposit contributes to the account and sum these amounts, we will have the value of the annuity on July 1st. We may express the value of this annuity as January's, February's, March, April, May, and June's deposits and interest. Factoring out the 100, we can rewrite this in the form of 100 times just the interest payments. If we look at the equation, x squared plus x to the n minus 1, I said squared, x to the power n plus x to the n minus 1 plus x to the n minus 2 plus dot 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 plus x squared plus x to the 1 plus 1. Then we can rewrite this in the form of x to the n plus 1 minus 1 divided by x minus 1. We have something to the power 5, the same thing to the power 4, the same thing to the power 3, to the power 2, to the power 1, all being added, plus the 1, which we can rewrite as that amount, 1 plus 0, 1, raised to the power 6 minus 1 divided by 1.01 minus 1, which gives us 6.1520. And multiplying by 100, we get $615.20. Formula for finding the future value of an ordinary annuity. Assume we are making irregular payments R into an ordinary annuity. The interest is being compounded m times a year, and deposits are made at the end of each compounding period. The future value or amount A is the annuity at the end of n periods given by the equation A equals R times the quantity 1 plus R over M, quantity raised to the power n minus 1 divided by R divided by M. To calculate this expression, you should do the following steps. First, find R over M and add 1. Second, raise that quantity to the power n and subtract 1. Then, divide the amount you found in step 2 by R divided by M. And step 4, multiply the quantity from step 3 by R. Example, finding the future value of an ordinary annuity. Suppose that Christian has a daily habit of buying a tall cafe latte that costs $1.95 at Starbucks 6 days a week. If instead he puts his money into an ordinary annuity, how much would he have in his account if he deposits his monthly savings in the annuity for 15 years? Assume that the annual rate paid on the annuity is 3%. Solution. Use the formula for the future value of an ordinary annuity following the 4 steps. Christian is buying 6 coffees each week, or roughly 24 cups per month, so R equals 24 times $1.95, or $46.80. R equals 3%, or 0.03. N is 15 times 12, which is 180. Step 1. Divide R by m and add 1, which gives us 1.0025. Step 2, take this quantity, raise it to the power 180, and subtract 1, which gives us the quantity 0.567431725. Step 3, take this quantity and divide by R divided by M, which is 226.97. Step 4, multiply the quantity from step 3 by the regular monthly payments, $46.80, yielding $10,622 just for not drinking at Starbucks for 15 years. Would you rather have coffee for 15 years or $10,000? Sinking funds. You may want to save regularly to have a fixed amount available in the future. The account that you establish for your deposits is called a sinking fund. Because a sinking fund is a special type of annuity, it is not necessary to find a new formula. We can use the formula for calculating the future value of an ordinary annuity that we have stated earlier. In this case, we will know the value of A and we will want to find R. Assume that you wish to save 1,800 in a sinking fund in 2 years. The account pays 6% compounded quarterly, and you will also make payments quarterly. What should be your quarterly payment? Solution. There's a typo here. That 180 should just be in. And then we're looking at the ordinary annuity future amount formula. We want a value of A to be 1,800. The annual rate of R is 6%, 0.06. The number of payments is N equals 2 times 4, which is 8, and M, the number of payments per year, is 4 because we're paying in quarterly. Step 1, R divided by M plus 1 is 1.015. Step 2, 1.015 raised to the power 8 minus 1 is 0.126492586. Step 3, that quantity divided by R over M is 8.432839106. Therefore, we have A equals R times the quantity we've found, or 1,800 equals R times 8.432839106. So solving for R, we get that R equals 1,800 divided by 8.4328399106, which is approximately equal to $213.46.